Welcome back, everybody. This is Mr. Diamond again, and this is the follow-up to that balancing video, the one that was really short. We're going to go through and we're going to practice balancing, and I'm going to talk you through the thought process that I do whenever I balance reactions. Now, some people like to list them out. They list out all the elements and they keep like a tally of them, and that's useful and that works, and you can do that, but it's kind of going to take up a lot of your time if you do that on every single problem. So instead, what I like to do is I like to kind of mentally just go back and recheck the problem as I am working through it. Let me make sure this pen works. I don't know if it's going to keep working. It looks good. Okay, we'll keep using it. It'll probably die as soon as I start the first problem. So again, in this first problem, what I like to do is actually, I'm going to switch from a pen. So my usual recommendation is to do this with pencil. I'm confident enough that I will do it correctly that I can do it in pen. But on these, I really think pencil is actually probably the better approach to take, just because the method that I like to use requires you to sometimes go back and change an answer you've already written down. And since you've got these blanks here, having to cross them out gets kind of obnoxious. So I've got NaBr plus Cl2 gives NaCl plus Br2. A couple of things that I look out for. I check if everything is only in one place. And so what I mean by that is there's only one place that has an Na over here and only one place that has an Na, one Br, one Br, one Cl, one Cl. Location-wise, there's more than one Cl, there's more than one Br. But there's only one location that has them. For example, down here, there's two O's on the left side and only one O on the right side. That's two locations the O is. That's going to make things usually a little bit more complicated. Second thing I look for is if there's any big chunks of elements that I can group together. So I can't do that for anything on this one. There'll be one like that on the next problem, though, and I can explain that there. Okay, so we're going to go ahead and we're going to look, and we're going to say there's one Na on this side and one Na on this side. Simple enough. We don't have to do anything to fix that one. There's one Br on the left, and there's two Brs on the right. So instead of just trying to list them out and figure it out, since I'm using pencil and I can erase it, I'm just going to go ahead and write a 2 and say, okay, well, let's see what that does. So then I've got two Nas over here now, which means I need two Nas over here now. And basically every time you add something or you change it, go back to the beginning and recheck everything and make sure that it's still going to work out for everything, or if anything's changed, you tweak it to make that thing that has changed correct. So I added that 2 in here for the Brs. That changed my NAs. So I added a 2 over here to balance this NA. 2 NAs, 2 NAs, 2 Brs, 2 Brs, 2 Cls, 2 Cls. So we are balanced. We're good. I'm going to go back and add 1s here. If the blanks are written like on the first worksheet for this, you have to go back and add the 1s. Otherwise, it looks like you just didn't finish the problem. If you are writing the problem out yourself on paper, for example, you don't have to add them because I'm going to assume that you didn't think they needed to be there since you wrote them. Okay. Next one's a little more complicated, just teensy tiny bit. So we've got PB plus Na plus C2H5Cl gives PB C2H5 close parentheses 4 plus NaCl. Now this is where I was talking about look for things that are chunked together. This is kind of a big element, and this is kind of, or a big compound, and this is a big compound. But if you notice, this C2H5, there's only one place that has carbon, there's only one place that has hydrogen, there's only one place that has carbon, there's only one place that has hydrogen. So instead of trying to balance just the C's and just the H's, it's a lot easier if we just try to focus on, well, let's keep the C2H5 together. And over here, there's 4 C2H5s. So I'm going to put a 4 out front of my C2H5. That means I now have 4 Cls, so I'm going to have to put a 4 out front there. Now I have 4 NAs, so I need to put a 4 out front there. I have 1 PB, 4 NAs, 4 NAs, 4 C2H5s, or 8 Cs, and 20 H's. And then I have 4 C2H5s, or 8 Cs, and 20 H's. And then I have 4 Cls and 4 Cls. One other check that we have to make sure that your final numbers out front can't be reduced. In this case, we cannot reduce them all by one thing. These all have 1s, and this one has a 1, which means it is in its most reduced form. Okay, the next one gets a little more complicated because we have O's in 2 separate places, but you kind of get to fall back on some other rule, which is if we look at this, we have CO plus O2 gives CO2. Our C's are balanced, but our O's are not. This side has more O's, But since O's are only in one location on this one, I know I'm going to have to change this number by something. So I'm just going to start trying stuff. I'm going to see what happens if I put a 2 out front and see if that'll let me balance it. I know I'm going to need at least more than one of these because I have 3 over here, and 2 is too small to ever get 3 to match up with it. So the next step up would be to put a 2 in front and make it so there's 4 O's. So now I have O2 here, but I also have 2 C's. So let's put a 2 out front of there, and if you look, 2 C's, 2 C's, 2 O's, 2 O's, 2, 4 O's, combined with those 2 is 4 O's, so we're balanced. So anytime you have multiple pieces on one side and only one piece on the other side, if that piece is smaller that's alone, start by trying to change that one and then using that piece to figure out what the other pieces could possibly end up as. Okay, next example, we have Ca3P2 gives H2O, and then, or plus H2O gives CaOH2 plus pH3. Now, the tricky part about this one is actually there is a hint that you can use that will help you figure out some of these problems, and that is thinking of water as HOH, hydrogen hydroxide, or hydrohydroxic acid. Either one of those works. And the reason that's useful is because then you can split apart, and we can see this first case, there was like, well, there's O's and H's, and then there's H's right here. They're kind of separated apart. This lets us see that this H split over here, and this O split over there. We can actually see that they split apart from each other. So at the very least, I know that I'm going to need to be able to get 2 O's, or 2 OH's out of this, but I also need to somehow get 3 H's. So if I put just a 2 here, I'm not going to have enough H's. And if I put just a 3 here, I'm going to have too many O's. So what we're now going to have to do is kind of look at the other pieces. So in problems like this, it'll actually help you a lot, and sometimes it'll balance itself. If you just focus on one part and you get like laser focused on like, okay, I split apart the water, I want to balance the H's and the OH's, yeah, that'll work. But if we go and we actually just start at the very beginning, we have 3 CA's, so this needs to be a 3 here. We have 2 P's, which means this needs to be a 2 here. That keeps our CA's together, and that keeps our P's balanced out. And now if we look, we have 6 OH's, and we have 6 H's, which means we need 6 waters to get that to balance out. Now, I'm going a little quick with this. I know I could be giving a little bit more explanation for it, but I'm assuming most of you have a little bit of practice with this. If you do not, obviously, I will be happy to help walk you through this a little bit more and explain it a little bit better. Again, I'm just kind of assuming that most of you have a little bit of practice with this. Okay, we have NH4 in O2. Then we have N2, and we have H2O. Now here, it's really hard to tell. There's no NH4s, there's no nitrites over on this side. There's just N by itself, and there's H2O by itself. And in this case, instead of trying to chunk it out to pieces, make sure you just check all of your elements first and go through it element by element. We have 2 N's, we have 2 N's, we have 4 H's, we have 2 H's, so we'll put a 2 out front. We have 2 H's, or 2 O's, we have 2 O's, 4 H's, 4 H's, 2 N's, 2 N's, and look, it's actually already balanced. So a lot of times whenever you see something that looks like there's just pieces that don't line up at all, they don't even seem related to each other, sometimes just checking the individual elements will count, or by counting them individually, will show you that you're actually really only like one step away from getting them balanced. Okay, so that was a couple of examples of varying difficulty levels. I assume most of the examples you've done before involve stuff like this. You probably didn't have any as complicated as some of these later few, but I've kind of shown you the hints that will help you along the way. Grouping together big chunks if they only show up in one place on each side. So this C2H5, C's and H's only showed up as C2H5s on each side, so that was a hint. If you have 2 things on one side and 1 on the other, take the one that only has 1 and use that to help you try to figure out the other pieces. If you get focused on, or if you have a water, remember you can split water into H and OH. Also, don't get too laser focused on one piece. In this case, looking at all of the elements before you try to balance them, you can kind of find some of them are a little easier. This was a lot easier than trying to balance out these H's and these OH's, and it actually ended up giving you the correct answer. And then finally, if you have something where nothing seems to match up, just count your individual elements and go from there. Sometimes you'll realize that it's a lot easier than it looks at first glance. All right, that's all I've got for you in this video. If you have any questions, please shoot me an email. Otherwise, this is Mr. Diamond signing off. Have a great rest of your day, everybody.